Hello, welcome back. Today we're tackling day 21 of Advent of Cyber. We're about to get our hands dirty with some serious malware analysis. But first, if you haven't gotten started with the event quite yet, this is your sign to jump in and help take down Malhare. We really need you on the team. This is Advent of Cyber by TryHackMe. It is a completely free 24-day event where we learn real security skills from hacking web apps to today's malware dissection, all while trying to save SOCMIS from the chaotic King Malhare. And the stakes are huge. We're talking about a prize pool worth over $150,000. Just by completing daily tasks, you're entered to win insane gear. iPhone 17s, MacBooks, rubber duckies, flipper zeros, and tickets to DEF CON. I put the link down below. Go sign up, get your prizes. Now let's get back to the challenge. Over here we have our malware analysis room where we're gonna explore Malhare.exe. Let's take a look at the story to really see what we're getting into today. In our kingdom of Wareville, just like in others, thousands of files of all kinds pass through the systems every day. But have you ever wondered which of these might be malicious? Which ones could actually belong to King Malhare himself? An interesting question, isn't it? So what are our learning objectives today? So in this task, the TBFC SOC team, aka us, really with that defensive perspective, we're gonna be investigating one specific file type, the HTA format. HTA, you can hover over it if you'd like to read more, but it's essentially a type often used for legitimate purposes, just as frequently exploited by attackers. But your mission is to reverse engineer that file and uncover how King Malhare really tricked all Wareville's elves to do this. So we're gonna look for application metadata, script functions, any network calls or encoded data, as well as clues about the exfiltration as well. We do need to start the attack box, but you don't need a VM today for what we'll be working on. No split screen is gonna be available for this either. There's no direct link and we don't need any extra credentials to connect to anything else. All right, knowing that we need to start the attack box, let's go right ahead and start it at the very top here. Oh, look at that. They already updated my VM's region for better performance. Love to see it, TryHackMe. As your machine is getting ready, let's see what we're gonna do next. And to note, we are using an HTA malware file, so do not run this on your local computer. That's why this attack box is really gonna come in handy, so we can look at it here. Now that we have the attack box running, we see our terminal, everything good to go. Let's check that off. Ooh, so satisfying. Look at that. Let's move on to task 2 for malware analysis. Some history knowledge here because not long ago in the summer of 2025, researchers discovered that ransomware groups were using HTA files disguised as fake verification pages to spread the Epsilon Red ransomware. During that campaign, many organizations were affected. So what exactly are these HTA files? Short for HTML application. So think of it like a tiny Windows app dressed up as a web page. It's got HTML, CSS, JavaScript, all the normal web stuff. But instead of running in a browser, it runs directly on Windows using HTA.exe. So it looks innocent, but it can actually execute real commands on your system. In Wareville, our hardworking elves use HTAs all the time. They help automate setup tasks, run internal tools, test quick prototypes, and keep the IT gears turning without building full-blown software every time someone needs a button to do a thing. They're convenient, lightweight, and part of the daily workflow. But here's the problem. That same convenience makes HTAs the perfect disguise for malicious nonsense. The elves need the legit ones to keep SOCMIS running smoothly, and we need to hunt down the fake, shady ones that King Malhare keeps sneaking in so they don't grind the whole operation to a halt. Before we take a look at the HTA files, it's really important for us to notice its structure so we can recognize any suspicious things that Malhare can be trying to, surprise us with. We can't have that happen. It's very similar to a regular HTML page. An HTA file usually contains 3 main parts. We're looking at the HTA declaration. This defines the file as an HTML application and can include basic properties like title, window size, and behavior. The interface built with HTML and CSS. This section creates the layout and visuals such as buttons, forms, or text. And the script VB script or JavaScript, here's where the logic lives. It defines what actions the HTA will perform when open or when the user interacts with it. In this case, the user clicks on the button and this message pops up saying like, hello from Wareville. But this is just an example to give us a feel of how the normal structure is so we can scope out what looks suspicious. So let's move on and take a look at how King Malhare is turning those HTAs into weapons, because we want to make sure that those get stopped. Not on our watch. We gotta protect the elves. Going into the HTA files, here's where things get fun or completely disastrous. If you're an elf who clicked the wrong thing, they're basically cheat codes for bypassing security. Attackers use malicious HTAs, as we're seeing here, for all kinds of shady jobs, sneaking in through phishing emails, quietly downloading second stage payloads, hiding encoded commands, or calling built-in Windows tools so they don't leave obvious footprints. It's basically living off the land wrapped in a fake web page outfit. Most malicious HTAs boil down to two things. One, they download more malware, or two, open a secret line back to the attacker. Tiny file, big problem. So here's a perfect example. King Malhare's Angry King HTA. It looks like a normal HTML app until you hit the script section. Suddenly you're starting a VB script, spawning PowerShell, decoding base64, pulling a payload from some shady C2 server and running it in memory like it's nothing. Windows just shrugs because mshta.exe said, yep, I know this guy. Attackers hide their intent by stuffing URLs inside encoded strings, burying commands, or giving the file a cute title like salary survey, so you don't question it. If you see base64 in an HTA, assume it's hiding something spicy and start decoding, because Malhare absolutely uses that trick to mask his next move. Okay, so let's start the analysis. Let's extract the base64 code and let's actually inspect it with a tool like CyberChef. So I'm gonna copy that over. There's this really handy little spot right here to show the control bar. I'm just gonna go to the clipboard and I'm gonna paste that base64 for us so we can copy it over on the attack machine. And then we're gonna use CyberChef. So I'm gonna go right into Firefox here and let's go into CyberChef. All right. Now that we're here, we're gonna paste base64 as our input. So because we know this is from base64 for that string in that script that we checked out, let's just add in from base64 here. Once we do this, we see the output that goes straight into that C2 right there from what we saw. At the very end, we see a redacted.txt file. Okay, and if we read along, we see that they're trying to tell us some other points in that script that we should know about. U is holding the decoded URL, which is the location which the next script or payload will be fetched. C stores the content downloaded from that URL, usually that PowerShell script or text instructions. B converts that content into an executable script block and runs it directly in memory. So it's giving us the hint here to check out these specific variables to see where downloaded data could possibly be something that's happening next, because that's really a key indicator to just suspicious activity. And what we're gonna do next in our analysis is gonna be broken down into 3 simple steps. We're going to identify the script section as we did with VB script. We're gonna look for any encoded data or external connections like what we just did with base64 or possibly future HTTP requests. And then we're gonna follow the logic to see what's being executed or what's being sent out to where. So here's the situation that we're about to dive into. A bunch of elves got their laptops compromised, and the only thing they all had in common was a salary survey that they filled out. Turns out that survey came in an email with a sneaky HTA attachment. Our job, pop that file open in a text editor, poke around safely, and figure out exactly what Malhare hid inside. So let's get started. The first thing that we'll do is we're gonna go into the HTA to make sure it doesn't execute. But we're gonna pull up Pluma on the attack box by running the following command. So to run the command, let's go over to our handy dandy terminal. I'm gonna copy this over to run it on our attack machine. And I'm just gonna paste it right here. And we're seeing the HTA exactly how the room described it, the exact same thing. I'm gonna expand it here so we can check it out further. So the window onload fires the moment the HTA opens. No clicking is required, it instantly kicks off. Get questions. Get questions, as we see, reaches out to external sites, grabs some encoded data, decodes it, and then hands it off to provide feedback. Provide feedback collects info about the victim's computer, sends it back out, and then runs whatever malicious code Malhare tucked inside the download. And decode base 64 and RS binary to string are just the helper. So they're decoding encoded strings into something readable so the script can use them. In short, the HTA opens, grabs fake survey data, steals system info, decodes hidden commands, and executes whatever payload Malhare wanted, all automatically. To fetch the real actions being performed, we can check out the create objects. Internet Explorer.application lets the HTA reach out to the internet. Basically, it's a way of phoning home or grabbing whatever Malhare wants it to download. Next, we also see wscript.network, which pokes around your computer to pull system details like your username, machine name, or domain info, perfect for reconnaissance. And wscript, it gives the HTA the power to run actual commands on the victim's machine, like launching PowerShell or executing hidden scripts. So one object talks to the internet, one spies on your system, and one runs commands. Together, they're giving Malhare everything he needs to pull off his little stunt. So next, we want to see what the elves are seeing on their side of the screen. First, we need to figure out what is the title of the HTA application. We're gonna go all the way up. Right at the very top on line 4 is where we find it. So it's called the Best Festival Company Developer Survey. Wow, I think Malhare is really brutal. Let's put that right in there. Best Festival Company Developer Survey. Let's check it. Perfect. Look at that. Let's keep it up. So what VB script function is acting as if it is downloading the survey questions? Let's take a look. The getQuestions function spins up Internet Explorer.application in the background. It then navigates to the URL that points to the TXT file controlled by the attacker. Whatever text is on that page gets pulled into the variable result. So let's try that. And the function title is very self-explanatory, so it makes sense. Let's move on to question number 3. What URL domain, including subdomain, is the questions being downloaded from? That is so convenient because we literally just went through that. It is survey.bestfestivalcompany.com. Very interesting names here from Malhare. Now let's check it out. Beautiful. Let's take a look at the next one. Malhare seems to be using typo squatting, domains that look the same as the real one, in an attempt to hide the fact the domain is not the intended one. What character in the domain gives this away? As we saw with what we pasted, if we take a very close look, festival has 2 eyes. So let's put that right there. Next one, malicious HTAs often include real-looking data, like survey questions, to make the file seem authentic. How many questions does the survey have? In this div, we see it has the ID of questions. So we got 1, 2, 3, and then we've got 4. Let's put that number right in there. Let's go. Moving on to the next one. Notice how even code social engineering persists. Fake incentives like contests or trips hide in plain sight to build trust. The survey entices participants by promising a chance to win a trip to where? I feel like this promise will happen at the end of the survey. Oh yeah, right here. So all participants will be entered into a prize draw for a chance to win a trip to the South Pole. It makes sense why the elves are so psyched about this, right? They're being asked questions about an increase in salary, and on top of that, being sent to the South Pole. Come on. So let's enter that there. Nice. The HTA is enumerating information from the local host executing the application. What 2 pieces of information about the computer it is running on are being exfiltrated. We're looking for 2 object names here. In provide feedback, in wscript, we see that it's storing the computer name and the username. So let's put that into the answer. Nice, we're on a roll. Let's look at the next one. What endpoint is the enumerated data being exfiltrated to? Let's keep in mind that Malhare is fetching answers from the survey. That'll likely be in the provide feedback function. It spins up that hidden Internet Explorer instance. It then builds a URL that includes your data. And if we take a look at that URL, we see that it's ending with details, which is the endpoint on the attacker server that all of this is being stored. So let's place details right there. Nice. What HTTP method is being used to exfiltrate the data? This is where it is fetching that data. As we see, there's no post body, no headers, no form submission, just URL parameters. So it is triggering an HTTP GET. So let's put that here. Spot on. After reviewing the function intended to get the survey questions, it seems that the data from the download of the question is actually being executed. What is the line of code that executes the contents of the download? If we look here on line 73, so this is the moment the HTA fires the payload. It hands the decoded malware to PowerShell and runs it silently. We're asked for the line of code that's doing the execution. So let's just copy this entire line and let's paste it over. Nice. It seems as if the malware site has been taken down, so we cannot download the contents that the malware was executing. Fortunately, one of the elves created a copy when the site was still active. So let's download the contents from here. What popular encoding schema was used in an attempt to obfuscate this download? Let's check it out. We're just gonna go and copy the link address. Let's paste that on there. Let's go back into Firefox. Let's paste it over there. Of course, I want to say base 64 because that's what we have been seeing in this room this entire time. But let's actually decode it to double check and not make any assumptions. I'm going to copy this over. And then let's go back into CyberChef. They have a tab right here and I didn't even notice it. So now we're gonna paste that over and we're just gonna put from base 64 and it looks like we're right. So base 64. Nice. So the next question makes sense, which is what we did intuitively to check our work, which is decoding the payload. It seems as if additional steps were taken to hide the malware. Makes sense, because as we're seeing this function layout, there's a lot of things that are not clicking. So we needed to decode it a step further. So what common encryption scheme was used in the script? This might look complicated, like where do we even start to fetch these patterns to decode what's going on? But here's a cheat code. When a script loops over characters and shifts them by a fixed amount, that's ROT13. So this particular snippet that we see here is literally the ROT13 formula for A to Z and the lowercase version here. The malware author is doing something super common. The first layer that we saw is base 64 that we already checked out. And layer 2 is that ROT13. Layer 3 is really executing the decoder result in PowerShell. Let's put ROT13 right here. Looks good. So now that we've got that sorted, we got both layers down. Let's take a look at the last question for this room. We're almost there. Either run the script or decrypt the flag value using online tools such as CyberChef. What is the flag value? We're already in CyberChef. Now let's decode what we already saw as ROT13. Let's search. So nice, CyberChef's already got it for us. We already get the flag at the very end right here. Let's copy that on over and paste it as our last answer. Let's go. Congratulations, we just finished day 21 of malware analysis. It was so much fun to do this with y'all. Definitely learned a lot and brushed up on some skills myself. Nice work, you just crushed day 21 and pulled the mask off Malhare's little HTA trick. Seriously, solid job digging through this with me. Enjoy the win, stay curious, and have a grand old time through this holiday season. I can't wait to see what you do on day 22. That rhymed. All right, I'll see ya. Bye.